Welcome to today's Reducing Costs Through Reuse webinar presented by Kam Logic. This webinar will discuss how leveraging design reuse and new technologies from Siemens PLM Software can help you create innovative new products while at the same time reducing your design and development costs. Let's start by familiarizing everyone with Kam Logic. Kam Logic has been in the CAD/CAM CAE space for over 35 years. The company was established 16 years ago, initially focused on CAM, servicing mainly the tool and die shops in the area. As the market has evolved, Kam Logic has evolved. Interestingly, working our way backward from manufacturing back to the conception of the idea or design. Because we started toward the end of the process and worked our way to the beginning, Kam Logic has the fundamental knowledge of what has to be done to assure that each step of the process will result in a product that will actually work or fit into the next phase of development. Kam Logic has chosen to represent software and tools that enable our customers to fulfill the full cycle of product development. We consider ourselves integrators and partners for our customers, not just resellers. Kam Logic employs the three-legged stool strategy. First of all, we partner with Siemens, offering the complete integrated Siemens portfolio for design, machining, analysis, and product data management. We partner with 3D Systems for 3D printing and rapid prototyping, and Romer and Creaform for 3D scanning for inspection and quality. Now that you've heard a bit about Kam Logic, let's look at the benefits of reuse and development. In this presentation, we'll discuss the challenges that many companies face. These challenges include, how do I find existing data? How can I make ad hoc changes to existing data? How can I develop and design reusable parts and templates? And how can I adapt and modify geometry for efficient and seamless use by downstream processes? Now, what is the value of design reuse, and why has this become a key initiative for most leading companies? Design reuse has a direct impact on time and cost in developing new and innovative products. Some of the common benefits are a cost and time reduction. It's key to supporting a platform engineering strategy. It helps reduce inventory through part reduction and commonization, and most importantly, improves quality. Simply put, the ability to reuse parts and information provides savings in design time, procurement, manufacturing, and inventory. First, let's address the inability to find existing data to reuse. The ability to find existing data is one of the biggest issues when it comes to new development projects. In almost every activity you do, you start by determining whether there may be existing designs already available that you can use. If you're assigned a new job, you may recall that the part you're designing is similar to a part that already exists. You need to start by finding the existing part or design, perhaps by searching your CAD database by part number, and then you go from there. In a recent Aberdeen report, 46% of those polled stated that finding models to reuse is a key challenge. Simply put, if you cannot find it, you cannot use it. Companies can now leverage product data management capabilities, or PDM, to search for existing designs and part numbers. You can now leverage search filters and classifications to find standard parts and part families. In fact, companies today can now also leverage shape search capabilities. And equally important, once this data is captured, it must be shared across all your product development locations around the world. Companies around the world leverage Teamcenter and NX due to their tight integration. This integration is essential for fast access and promoting design reuse. NX's tight integration with Teamcenter's classification capabilities provide instant access to the classification search without exiting the NX environment. The designer, while still in the NX CAD session, can search for class members and attribute values. This includes ready-to-use standard parts libraries. The NX library consists of more than 100,000 standard parts, including screws, washers, nuts, bearings, pins, and other design items. These parts are available in ANSI, ISO, DIN, and other standards. And once the part is found, the designer can simply drag and drop directly into the assembly. NX also has a reuse library where parts and templates can be stored for other designers to use as they see fit. Geolus Search is a 3D search engine that will rapidly track down parts similar to a given example based on its geometry. The clear view of all the data gives you the ability to control and reuse parts, which provides savings in design time, cost estimating, procurement, manufacturing, and inventory. Let's take a quick look at the power of shape search technology.
Reusing geometry provides significant productivity and cost savings benefits. However, if strict naming and classification standards are not followed, there is little chance of finding the data. A text-based search on this data returns 2 turbochargers. Geolus is a technology that searches based on shape and quickly finds parts with similar geometry regardless of how classified. Here, Geolus searches on the same dataset using the collection of parts that comprise a turbocharger. Note that this is a geometry-based search and is independent of any text data and returns all 13 similar items. Early in the design cycle, an engineer has created a simplified design of a part. This is enough for Geolus to search for similar parts in the company library. If there is a close enough match, the engineer can use the existing part rather than waste precious resources doing work that's been done before. A result can be opened as the new current part or inserted into the current assembly. As you can see, the shape search returns 2 close matches to the simplified part. Their names are quite different from each other. This shows how Geolus overcomes the problems presented by inconsistent naming or classification. If this existing part exactly matches our needs, then we can use it, or we can treat it as a template and adjust it to our requirements. This is much more efficient than designing a new part. In this case, we'll use Synchronous Technology in NX to increase the height of this pump cover. Note that we select both the inner and outer faces. This is to maintain the thickness of the pump. The part navigation tree provides an undo, redo control for this edit. The combination of keyword and geometry searching is very powerful. Here we use the keyword pump to find at least one item of the type we're looking for. The graphical format of the results makes it easy to identify a part whose geometry can be used to find all items similar to it. The part is effortlessly loaded into NX, where it is inspected to verify its correctness. Geolus is then used again. This time we use the geometry of the pump piece to find the other parts. Here, 2 parts have been returned. A single keyword search would not have returned both parts. In this last scenario, you see that Geolus even returns finite element models that are similar in shape to the originating part. This enables engineers to cross-reference and reuse knowledge associated with FEMs of a similar shape. In summary, Geolus is a 3D search engine which rapidly tracks down parts that have similar geometry. It provides a great opportunity to cross-reference records of similarly shaped parts. It provides an environment for savings in design time, cost estimating, procurement, manufacturing, and inventory.
Now, once we've leveraged technology to find the designs, what's the best way to modify a design once it is found? The problem with traditional CAD technologies is that a single CAD model is typically composed of many features which have many interdependencies. While these interdependencies are powerful during the work in process phase of design, it becomes very constraining for design reuse. As a result, companies overall are faced with designs that are often inflexible and unable to adapt to changes. In fact, in a recent study by Aberdeen, 48% of the companies interviewed are continually faced with inflexible models that fail after changes. Aberdeen research also points to the fact that the modification of these models requires expert CAD knowledge. This inflexibility results in lost time and increased product design costs. So, how are companies addressing these issues? According to Aberdeen's study, of 71% respondents addressed the issue by training their users to increase their CAD skills. In addition, 64% of respondents are attempting to design their models for a wide range of later modifications. This usually ends up with the same result. It's almost impossible to anticipate how a model will need to be changed for a future design. In both instances, this is costing the companies time and money. Traditional modeling approaches give designers the power to parametrically modify the construction recipe of a model. They can build in model logic for anticipated changes or pre-plan the relationships between elements to allow for easy modification. Now, the problem comes when change isn't anticipated. Complicated history, otherwise known as feature trees, can be very difficult to manipulate by someone other than the author. Anyone who's worked with a complex CAD model's history knows how much knowledge is required to modify the logic or parametrics for the proper design outcome. Additionally, reusing parts from earlier versions can be difficult with some systems because it's hard to know how the part was designed, and data from other CAD systems doesn't have any parametric information or feature history to control how it can be modified. There is a better approach. Design reuse doesn't have to mean remodeling. With NX, you can quickly grab geometry and make changes, regardless of how the model was built. There's no need to plan ahead for reuse, and no need to understand the intricate details of how the model was originally designed. NX provides predictable results with synchronized rules, features, and geometry. With synchronous technology in NX, you can create designs in a more natural and simplified way. You can add constraints whenever and wherever you want, but they're not required. There's no need to pre-plan designs or spend time worrying about the model's future use. When modifying a model, simply select and drag or edit the shape. The intent is applied and preserved at the time you need it when editing the geometry. With NX, you can virtually edit any model as if it were your own, instantly find geometric relations, and treat sets of geometry as features rather than just faces on a model. There's no requirement or need to plan ahead for reuse. With NX and synchronous technology, you can edit data from other CAD systems faster than even they can. NX allows you to work in context of the assembly. You can edit any parts within that assembly regardless of where the data was authored. With NX, you can directly open in and work with data from CATIA version 4 and 5, Pro E, and SolidWorks. Of course, NX also supports IGES, STEP, and DWG to help you work with design data from multiple sources. Scrapbook modeling is another method to increase the ability to reuse geometry. NX supports a workflow that allows users to cut or copy and paste sections of a model. This capability will work inside a single file or across multiple files. The cut and copied geometry preserves design intent, allowing the geometry to adapt to the new model conditions when it is pasted into place. This can include automatically trimming the geometry to the new model and reapplying any blend geometry as necessary. This approach can significantly reduce design time and promote the reuse of geometry. These features can be added at any time to a feature library for anyone else to reuse. In this next video, we'll see the power of NX in a MultiCAD environment.
Let's take a look at this aircraft tail assembly to examine some of NX's MultiCAD capabilities. This is JT data with XT BREP, so we can convert it to model data. This assembly has been converted to history-free mode. Now we will change the thickness of the swing arm and the positioning of its mounting ribs. Using Face Finder, we can pick one side of the rib and the offset option will automatically select the other side. Then we pick the corresponding face from the other component. Once we make this change, we can select the same surfaces on the other side and change them. The other thing to notice here is that we can pick the geometry we want while de-emphasizing what we do not want. Using synchronous technology in the context of an assembly is a fast way of getting the changes you need when dealing with MultiCAD data and MultiCAD assemblies. Let's take a look at how NX with Synchronous Technology allows us to edit MultiCAD data. We have opened a CATIA V5 CAD part file. The first change we want to make is to modify the mounting flat and its two holes. We pick the planar face and then use Face Finder to find the boss and pocket faces. We can quickly locate the geometry we need to change and rotate it around the center axis. Face Finder works regardless of the fact that there are no features on the model. To finish, we will adjust the height of this inside step. You can see how Synchronous Technology adjusts the geometry. Now we will make a more complex change to this CATIA part. We want to change the radius of these blends, but one of them is not recognized as a blend, so we can't select it. We can fix this using the Replace Blend feature to turn BREP surfaces into blends. First, we can have NX highlight all of the surfaces that could potentially cause problems. Then we can decide what we need to do. In this case, we are just going to replace the one blend. Once that's done, we can modify the radius, changing it from 5.5 millimeters to 4 millimeters. This is just one of the tools NX has to make working with MultiCAD data easier and more productive. Now we will make a bigger change to the CATIA part. We are going to change the blend that runs around the outside of the body. Unfortunately, this blend cannot be edited, so we're going to use Optimize Face to clean up the geometry. MX can highlight areas or geometry that might be causing a problem. This allows you to pick which geometry you want to optimize. You may choose not to optimize the whole model, as this could be time-consuming. In this case, we are going to pick around the geometry and select the highlighted faces. After doing the optimization, you get an optional report, which shows you what the system has done. In this part, you'll see that the number of B surfaces has been reduced from 248 to 74, and the number of blends increased from 8 to 183. These changes mean that the geometry is much more reliable for editing. Now we can go ahead and modify the blend on the side of the model. We can pick the blend faces that we want to change the radius on, and we no longer get an alert when picking them. Optimize Face has converted the B surfaces into blends to make them editable. We're going to make a significant change to this blend by changing its radius to 60 millimeters. Once this is done, you can see how the overlap conditions and all other blends have been updated to maintain model integrity. Now let's take a look at how NX can add intelligence to MultiCAD data. If we move the top face of this component, you can see how the chamfer on the side grows. This is not the desired behavior. The Label Chamfer command allows us to build the proper relationships into the model. When we pick the chamfer face, the system identifies the adjacent faces. Now when we move the top face, you'll see that the outer chamfer is updated correctly. You can also make changes to chamfers, either size or shape. After we pick this chamfer, we change the type to be symmetric. It's also important to remember that while this demo shows changes to a single edge chamfer, it is possible for chamfers to span multiple edges, and those can still be modified as well. Now we will add more intelligence to this CATIA part by adding a dimension to control the distance from the top of the flange to the small step. We will keep the size at 2 millimeters and use the lock dimension functionality to build a constraint between the two faces. To recap, we have added intelligence to MultiCAD data. Nobody else in the market can match this ability to add extra value to imported data.
Okay, now another important reuse capability is having the ability to develop and design reusable parts and templates. This includes system templates, part libraries, product templates, and more. One example is the Reuse Library. The Reuse Library is a common platform for quickly finding a wide range of reusable design objects. It allows users to drag and drop objects into automation workflows. This seamless, knowledge-driven solution allows you to design, digitally prototype, evaluate, and manufacture much faster. It also allows you to maintain quality and adhere to standards. Product Template Studio uses a similar drag-and-drop environment to help overcome some of the traditional problems faced when reusing knowledge and data. PTS provides rapid generation of reusable design templates and allows any design to be adapted for reuse. With PTS, engineers can publish the key design variables for a component or assembly, and these become the key driving parameters that control the environment and control the product. PTS brings codeless customization to the designer, enabling design for reuse strategies to be easily implemented and delivering a solution that extends the benefits of parametric modeling in an enterprise. These templates can then be stored and accessed from the reuse library directly from within NX. PTS users report 80 to 90% gains in productivity and greater than 90% reduction in template authoring time. Let's take a quick look at how Siemens Product Template Studio uses a simple drag-and-drop environment to help overcome some of the traditional problems faced when reusing knowledge and data.
In this movie, we will show how we can update existing data with new data. First, we can see the existing body side and the new B-pillar, which is based on a template. Then, we can take a look at the new body side surfaces, which are designated as new theme in the assembly structure. We will need to match up with these surfaces. The existing body side parts are linked to the new body side surfaces using General Relinker. Scrolling through the links, we see that one curve fails to relink to the new surface. We next edit the template part to fix this linking problem by selecting the correct die curve. The automated linking process in General Relinker works very well, but just in case it does fail, there are tools that can easily fix any kind of problem. Next, we add some conic blends near the top of the B-pillar. The conic blend can transition from a flat surface to the round shape of the blend more gradually than a normal blend with a circular cross-section. Unlike a normal blend, which makes an abrupt transition from flat to whatever radius the blend has, the conic blend increases in curvature according to a parameter called rho, producing a better-looking blend. Next, we go back to the template part that's driving the B-pillar so that we can make some changes to it. The parameters that make up the template part are editable, such as the radii of the inside openings. After modifying these radii and performing an update, you can see the final part change. Comparing the newly modified B-pillar to the body side, we can see that they match up now.
Okay, now we have looked at how with Reuse Library and Product Template Studio, you can manage and reuse what you need when you need it by using easy-to-create templates. The next challenge you face is, how do I adapt and modify geometry for efficient and seamless use by downstream processes? In simulation, Synchronous Technology and its associativity to the CAD model allows the analyst to edit and try multiple design alternatives very quickly. Common functions for the analyst may require removing features to simplify the model for analysis. Another function for the analyst may be removing ribs or bosses to optimize the design. Whatever the case, this technology aids the analyst in getting an optimized design in the most efficient manner. Now, for those who want to leverage the power of NX CAE Suite and its powerful NX Nastran solver with other CAD formats, this is not an issue. The ability to make these edits is irrelevant to what system the model was designed in. For manufacturing, the same needs apply. Manufacturing engineers in the part programming process require the capabilities to add material for roughing operations or to remove features that need to be matched later in the process. When manufacturing or forging or casting, the manufacturing engineer is typically stuck with a model that has all the machining features. In many instances, this comes from an OEM. With Synchronous Technology, NX provides the capability to quickly and easily get back to the net shape to start the process. Let's take a quick look at an example.
NX, powered by Synchronous Technology and its analysis to design associativity, enables engineers to quickly make design changes on the fly, as shown in this plastic case example. You can delete holes or other features from the design that are not relevant to analysis. Next, you can quickly modify dimensions of various geometry features throughout your model to achieve performance requirements. In fact, you can even drag entire sections of your geometry around, and NX automatically maintains design relationships, as you see here as the boss merges with the rib in this example. Since the analysis model is associated to the design, you can quickly update your model to the new design. With this process, you can easily iterate and simulate over several design alternatives in a fraction of the time it takes with traditional CAE tools.
Okay, now we've seen how NX's seamless, knowledge-driven solution provides the capabilities required for CAE tooling or to quickly prepare geometry for manufacture. To summarize today's challenges, how do I find existing data? Find geometry by name, number, or shape using seamless, knowledge-driven solution with Teamcenter and its tight integration to NX, along with Geolus shape search technology for fast access and promoting design reuse. How can I make ad hoc changes to existing data? Design freedom, powered by Synchronous Technology, allows designers to focus on the product design, not the CAD tools. This patent-pending technology delivers real value and allows your engineers to be much more productive. How can I develop and design reusable parts and templates? NX and Teamcenter provide the ability to easily develop and design reusable parts and templates. This includes system templates, part libraries, product templates, and more. And how can I adapt and modify geometry for efficient and seamless use by downstream processes? NX's seamless, knowledge-driven solution provides the capabilities required for CAE, tooling, or to quickly prepare geometry for manufacture. Now, many companies are taking advantage of design reuse. Samsung is recognized as one of the fastest-growing global brands. Samsung leverages a fully digital design-through manufacturing approach. This approach provides greater efficiency in product design. Samsung recognized the importance that design reuse could add to not only reduce costs, but also help increase the number of new product innovations. Samsung added reuse as one of their core business initiatives. The ability to find and reuse previously validated CAD data has helped shrink the development cycle by 30%. In addition, Samsung's process for evaluating designs is now much more effective. Samsung's approach to design reuse has reduced the need for physical prototypes by 30%, and their automated BOM generation has reduced errors by 95%. In fact, by focusing on these key initiatives, Samsung has been able to develop and innovate high-tech products 30% faster. Now, I trust I've been able to demonstrate the importance of design reuse and its potential contribution to improving the overall product development process. Also, we've seen how NX from Siemens PLM Software can help you achieve a reuse strategy. We'll be covering the additional features and benefits of design reuse inside of NX in the upcoming webinar on December 6th. If you attended today, you're already enrolled in that Part 2 webinar. Thank you for your attention and taking the time out of your busy day to attend this webinar. If you have any questions on NX, if you'd like a demo or any more information, please call me at the number below, and we'd be happy to help. And thank you, and have a great day.